So what are patterns essentially? I'll pretend that everyone here is new. So patterns actually are not applicable only to Java language. You can use them everywhere, almost everywhere. And this is actually about mindset. So when you're constructing your program, when you're thinking about your objects, doesn't matter what language you use. Is it Java? Is it Python? Is it something else? Maybe JavaScript. For God's sake, I don't use JavaScript almost at all. So it's the way of thinking. How do you think about your objects? In which ways are they going to work together and stuff like that? But anyways, let's start then. So a few words about me. My name is Elena, like I already said, and I'm currently working as a team lead at some secret startup. I'm not going to reveal the name just yet. All in all, I've been working in IT for more than 9 years in different roles. I've been mostly a backend engineer, using languages like Python and Java mostly. I did a couple of years in machine learning field and in big data field as well. I worked in companies like Babylon Health, maybe you heard about it, especially if you're in the UK. I worked at Cisco, but that happened when I lived in California. And also I worked at Palantir, another company that exists both in US and UK and also in some other countries. Anyways, moving on. So today's agenda is going to be, we're going to cover some patterns. Then there'll be a short quiz and a Q&A. But actually don't hesitate to interrupt me and to ask questions as we go on the slides. Yeah, don't be shy. It's supposed to be a friendly environment here tonight. So yeah, so let's go. Today we're going to cover 5 structural patterns, the names that you can see here, and we're going to start with an adapter. And don't be scared, adapter is just an adapter. So probably if you have traveled anywhere, like anywhere outside your country, probably you have faced the problem with the power plugs, right? EU and UK and US, all of them use different plugs. So if you want to charge your mobile phone, you need to buy an adapter. Same way here. Again, doesn't matter if you use Java, if you use Python, whenever we're talking about the objects, we think in patterns. Here's the adapter pattern. Let's go through a tiny example. So imagine we have some interface of the bird, and birds can make sounds, right? Different birds can make different sounds. So let's create a sparrow that is a bird, and it can definitely make a sound. So what sound does sparrow make? I actually don't know how I'm supposed to read this, but it's like chirp, chirp. I don't know. Can anyone help me? What is the sound that sparrow makes?
That was right. Chirp, chirp.
Chirp, chirp. Cool. Thank you. Because like I'm not a native speaker, so sometimes these things confuse me. Maybe in my native language, I would say that sparrow says chirik, chirik, which is definitely different. So on another hand, we have another interface, toy duck, and toy duck can squeak, right? So different toy ducks probably are squeaking differently. So let's create some plastic toy duck that squeaks. I think we lost you.
I know, yeah, she's frozen. Tell her in the chat.
We cannot hear you, I think. It's too... That's fine.
Do you hear me right now?
Yes.
Yeah.
Yes.
Oh, that's cool. So, yeah, we have, as I Googled, there are some outage for Zoom today. So I couldn't connect from my laptop. So I couldn't run the presentation on Women Who Code London today. And I can't do it from my phone, but from my phone, at least I could connect. So yeah, let's wait a bit for Elena. She said that she reconnecting right now. So yeah, in the meantime, every time when we run these sessions, I ask people to type in the chat where you connected from. I like that we have these events online, so we can run them all over the world. So we have people not only from London. So yeah, please type in the chat where you connected from. In the meantime, while we are waiting for continue. Oh,
I already
wow.
came back.
Oh, yeah, that's cool.
Yeah, apologies. Like I mentioned earlier, I'm coming from a countryside house and sometimes power breaks happen. So, oh, so many Londoners. So nice.
And not only, which is
not only.
cool as well. Like,
Yeah.
could you see it? San Francisco, New York, Belgium,
Oh, wow.
Barcelona. Wow.
I bet it's a nice weather in Barcelona right now.
Yes, definitely.
Okay. Sorry, let me share my screen again and we'll continue on the birds. So, okay, how do I turn on my camera now? Okay, cool. So, again, we created our toy duck, which is a plastic toy duck, and we created our sparrow, and we want them both to squeak. But sparrow cannot squeak, right? We don't have a method like that, right? It can only make sounds. So what do we do if we want to work with both of the creatures simultaneously and on the same method? We can create an adapter. So again, we can imitate that our bird is a toy duck in the same way how we treat our UK power plug to be a US one when we use an adapter, right? So here what we do is the following. We create a class named bird adapter that implements the toy duck interface. Why does it implement toy duck? Because we want all the creatures to be able to squeak. So in this bird adapter, we're going to pass the bird that is going to pretend to be a toy duck. And then when this pretending bird squeaks, it actually makes a sound. So now we can use our program, write down our program like that. We create a toy duck, just like we did before. We create our sparrow. And now we are adapting a sparrow. See, we create an adapter and we put the sparrow inside. And now the adapted sparrow can squeak. Underneath, yes, it will still make sound. It will still chirp, chirp. But from the point of view of our program, it squeaks. Basically, that's it. That's everything that adapter does. Another example could be like, why do we, so maybe this example is a little bit too unrealistic. So maybe in real world, why do we use this? Imagine you're working with two libraries and you have your stock data provider, right? And you want to analyze it somehow, but your stock data provider gives you data in XML format. And then you were poking around internet and found some analytics library, some like the coolest analytics library that will help you to find the best stocks ever to invest into. But there's a problem. Analytics library takes JSON inputs. So obviously you cannot control your stock data provider. You cannot edit this code that returns to XML. You cannot control your analytics library. You cannot edit it so it takes XML as input. So what do? Of course, here in the middle will be your adapter. You're going to create a class that takes XML and gives JSON as output. Let's take a look at the class. So you have your XML library, and this is a pseudocode. Obviously, there is no such type as XML and JSON. In Java, it's just a pseudocode. So you have your external XML library, and it has a method getTransactions, and it will return to you XML. And then you have your JSON library that takes JSON as input. So if you want to use them together, you cannot do this, right? You cannot create JSON lib and XML lib and put XML lib getTransactions as input, because XML lib getTransactions will return XML, while JSON lib calculate metrics wants JSON input. So instead, we're going to adapt our XML library. We're going to create a JSON adapter, and again, we are creating here a constructor. We save the pointer to XML library, and then we have a method getTransactions, and now it will return a JSON. See, underneath it will still call the original XML lib getTransaction method, but it will output a JSON. So now we can use both of the libraries together through an adapter. Again, every time when you're hearing adapter pattern, think about plugs. You have a plug and you need to charge your phone, so you need an adapter when you're in another country. In terms of classes, this is a nice diagram that I shamelessly stole from one nice website that I'm going to tell you about in the end. There will be a list of the materials I used for this presentation. So what are we doing here? We have some client interface that wants to call some method, but this method is incompatible with service method. So if we want to make a client interface work with service, we need an adapter between them. That's it. Adapter wraps a service inside it and calls the method underneath. Interface is happy. You cannot change the interface. It always expects to call the method. Basically, that's it. Let's talk about pros and cons. So why is it beneficial to use this pattern? First of all, here comes a single responsibility principle. So instead of changing your service or client interface classes, even if you have access to them, even if it's not a library that you download from the internet, but you have written them yourself, your service should not care about your client. So like if client wants to work with XMLs, it's client's right. If you're trying to add a method JSON output to an XML library, that seems weird. So please just extract every adapting logic to an adapter. And here comes also an open close principle. So like you can create as many adapters as you need without breaking or changing existing classes. You have already 2 classes that work, they just don't work together. So to make them work together, you need an adapter. And obviously everything comes at a price. So yes, we are not changing existing classes, that's cool, but you're creating more classes, right? So more adapters you create, more classes your code has. So it's always about the choice. When are we using adapter? We're using the adapter when we have existing classes that have incompatible interfaces between them or with the rest of the code, when you cannot change one of these classes or both of them, and when there are a lot of subclasses. Imagine implementing the method in all of them. So example would be, again, going back to the birds. Imagine we had a lot of birds implemented already. So there would be like sparrows, there would be swans, I don't know what other birds are, doves, ducks, and maybe like 20 more. And imagine you would like to add a squeak method to a bird. Then obviously you have to implement this method in all of the classes that implement bird, right? So instead of doing that, just use an adapter. Let me take a look at the chat. What is the advantage of using this pattern, not creating a dedicated static method? You got your answer. Okay, cool. Okay, then moving on. That's it about an adapter. Let's move on to a decorator. Decorator is also a cool pattern, but let's start with the coffee first. So imagine you want some coffee and you go to your favorite coffee place, and then they'll ask you, what kind of milk do you want? Do you want to maybe coconut milk or almond milk? Do you want some extras like maybe whipped creams or not? So coffees. We have some beverages here, right? We have a description of a beverage and we have a cost of the beverage. And obviously, whenever you choose coconut milk, in the majority of coffee shops, the cost is going to be different, right? Higher, like plus 0.5 or something like that. So imagine we have some beverages, and beverages are house blend, dark roast, decaf, espresso, and others. So each kind of the coffee has their own cost. Maybe, I don't know, dark roast will be more expensive than espresso, and so on and so forth. But now imagine we want to, like I said earlier, have different variations. Like I want to have espresso with, not espresso probably, maybe house blend. I want to have a house blend with coconut milk and whipped creams. Or I want to have a house blend with double whipped cream and almond milk. Or the list goes on, and you end up with so many classes, right? You can see there are so many combinations of that. There's also like a caramel and soy, without soy. So imagine this mess. And each class has its own cost. So you can take and count, okay, you have decaf plus cost of steamed milk plus cost of mocha. But this is insane. You cannot potentially continue working with such a huge amount of classes. So what can we do instead? Well, maybe we can think about it as an attributes. Maybe we can add our milks and soys and whipped creams and other condiments as a methods, right? Like a list of method. So every time a barista will ask you if you want to have almond milk, if you want to have a whipped cream, we can just set whipped cream and increment the cost of the beverage. Maybe this can be a solution, but maybe not. Why not? Well, first of all, what if I want to have a double milk or double whipped cream? These methods can just do it like once, right? I can have only a single whipped cream. Then beverage is not only a coffee. Beverage can be a tea, and having a tea with whipped cream sometimes doesn't make sense. So maybe we should not implement all of these methods in the tea. So what can we do instead? Instead, this is a scary picture, I know, but trust me, it will be okay in a moment. Instead, we can have a nice pattern decorator and we can use it. So again, we have our beverage here still, like in the beginning, and we still have our 4 types of beverages and maybe a tea as an additional one. But what are we adding here? We are adding a condiment decorator. And we can say that our beverage can have milk or 2 milks or triple milks. We can have soy, it can have whipped and mocha. And as you can see, every condiment has a beverage inside. So how does it work, essentially? And maybe I will have to write something down. But anyways, let's start with the code first. And if it is still too complex, I will draw some pictures which can help. So we're starting with our beverage again. We have some abstract beverage that can have a description and that has a cost. And then we create a condiment decorator that is also a beverage. And you will see why in a moment. So our condiment decorator also behaves like a beverage. Why is that? Okay, So we create an espresso first, and we also create a house blend. They have different costs. Espresso has like 1.99, house blend is 0.89. What about the condiment? We create a mocha, and see, when we create a mocha decorator, it takes a beverage inside it. And whenever you ask for a description, it will give you a beverage description plus mocha, and it will take a beverage cost plus 0.20, right? So how does it work now? Imagine our main method. We have a beverage, we have an espresso, and this is just an espresso without any condiments. So if we want to print description and the cost, it will just take it from our original class from here. It will print espresso, it will print 1.99. Then a customer comes and says, can I have dark roast with double mocha and the whip, please? So what happens next? We create our initial beverage, new dark roast. Then we create our mocha and we pass a beverage inside the mocha. So the mocha wraps like a matryoshka doll, actually. It wraps a beverage. So then we create a second mocha, and again we pass the previous beverage. Then we create a whip, and it passes and pass the beverage again. And in the end, when we print the description and get the costs, all of these classes are going to be executed in a line. Let me actually draw it. I hope you will see it. Okay, I can draw something. So what happens here? We have our dark roast, and dark roast has a cost, I don't know, let's say 1.5, right? So this is what happens here. Then on this line, we say, okay, I want to create a mocha and pass a beverage inside. So this is dark roast, DR. Then we create a mocha, and inside the mocha, there is a dark roast. So this is mocha. And we say that, I don't remember how much, let's say it's going to be 0.5. Then at this stage, we again create a mocha, and we pass already wrapped dark roast inside it. So this is another mocha, 0.5. And in the end, we're going to create a third layer whip. So this is going to be a whip. And I don't know, whip, let's be, I don't know, 0.3, just because. So now, when we're calling our beverage, get description and beverage, get cost, what is going to happen? So beverage is now pointing at the whip, but whip knows about all the internal layers. Well, actually, it knows about only first internal layer, but this layer knows about the next layer, and like so on and so forth. So when we're going to calculate the cost, we're taking 0.3, and then whip is asking the next guy, okay, mocha, what is your cost? Mocha says, okay, my cost is 0.5 plus the object inside me. The object inside mocha is another mocha. So mocha asks, okay, mocha inside me, what's your cost? Mocha inside says, my cost is 0.5 plus the cost of object inside me. And the object inside is dark roast, so plus 1.5. Here's how we get the whole cost, basically. Again, the same thing happens with the house blend. Here you can see house blend with soy, with mocha, with whip. And it's going to calculate the thing like the same way, taking the cost of the whip, taking the cost of the mocha, taking the cost of the soy, taking the cost of the house blend. Basically, that's it. So let me stop drawing. There's a chat. Nice to explain. Oh, thank you. How do I stop now the drawing thing? Okay, stopped it. So here you can see the matryoshka dolls, like I mentioned earlier, because like all of these objects are like living inside each other, like matryoshka. How do I clear the drawing? Okay, clear. So this is how it looks from the perspective of the classes. Again, we have some component, and who is the component? It was a beverage, right? Component is a beverage. Concrete component is some type of the coffee or a tea or something like that. Then we have a decorator that expects a component. Oh no, internet survives. Okay, internet survived. And then we have concrete decorators like mocha, like whipped cream, like some sugar, like vanilla cream, maybe something else. And basically that's it. And then in the client, you just wrap objects inside each other. Maybe if you're working with Java for a long time, maybe you remember when you want to read something from the file, you create input file stream, and then like, okay, I haven't been doing Java for more than a year, but yeah, if you want to read from the file, you probably remember that you need to create 3 objects. It's like input file reader, buffered line reader, input file stream, and you also provide them inside each other. So pros and cons again. Pros, we can add new behavior without new subclasses. So if you want to add a new behavior like whipped cream or something like that, you just create one class, whipped cream, not this mess, not all the types of coffee with the whipped cream. Then you can combine multiple additional behaviors. So you can add a decorator with whipped cream and with caramel, instead of creating espresso with whipped cream and caramel. But there are also problems with it. Since decorators are applied as a stack, right? Like remember, there's like one circle inside, in another circle inside another circle. It is not non-trivial to drop a decorator from the middle. So again, taking the pen. So we have our initial object here. This is going to be like, again, dark roast. This is going to be a whipped cream. This is going to be a caramel. And this is going to be, I don't know, vanilla syrup, whatever, vanilla. So you have only the pointer to vanilla. And if you want to get rid of whipped cream, it's going to be not that easy. That's it. But I don't see why you would need to do that often. So maybe it's not a big deal. So when are we going to use the decorator? When you want to be able to extend behavior of your objects at the runtime, and when inheritance seems impossible in this case, too many combinations, too many classes to think about. Yeah. Thanks, Irina. So moving on to the next pattern, composite. When and what is it? First of all, let's think about, again, matryoshka maybe, actually. So let's think about your order from Amazon or from somewhere else. Maybe actually not Amazon. Amazon doesn't do that, as far as I know. Yeah, maybe some, yeah, FedEx order. So you have a box, and in the box, you have some receipt, and you also have another boxes, and other boxes you need to unpack. In this box, you have a hammer. In these boxes, you have something else. But as you can see, you can represent all this relationship in a tree-like manner, right? So here's a hierarchy. And whenever you see the hierarchy, you should think maybe recursion is needed. Buzzwords, I know, but let's take a look at it. Oh, wow, why is it empty? Okay, another example, not about the postage stuff. Imagine you have a company and you have a CEO, then you have a head of engineering, then you have a tech lead, then you have software engineers. Also a hierarchy. Imagine then we want to do something with them. What is happening? Why is it going twice? Imagine we want to give all of them a bonus. So what should we do in this case? Well, we can give a bonus to software engineer, but what does a bonus look like for a tech lead? Let's take a look. We have some employee, and employee has a method bonus. So when we call a bonus for employee, we give them a bonus. So we have a software engineer, and when we give them a bonus, bonus is applied. But also we have a team lead, and if we give a team lead a bonus, then the bonus also applies for all the child employees. So see, it's a recursion basically. With this example earlier, sorry, it's like a double slide. With this example of the postage box, you may think about, again, price. You want to know a price of this whole box. So how would you do that? You have probably a method price here. You have a price, and then your receipt has a price, which is obviously a 0 because it's just a receipt. You have a price. You have a price of the hammer. Maybe I should actually text it. Yeah, that will be faster. You have a price of the hammer. You have a price of the charger. You have a price of the phone. You have a price of the headphones. So you know what the price of the charger is. What is the price of this box? The price of this box is the price of all the objects that are inside of the box. So this is going to be a price of headphones. Headphones. What is the price of this box? This is going to be a price of phone plus headphones. And sorry, my typing. What is the price of this box? A hammer. See, so like coming from the leaves, you can ask the price of the composite object, and what it will do. It will go downstairs and ask all the objects inside of their price. It kind of looks like a decorator, right? But it's a little bit different because in decorator, you add and combine the new behavior. While here, the behavior is all the same. And the difference is only in the price method. So for a phone, the price method will be just, so like, let's say get price. It will be just return this price, right? But for the composite object, for the box that contains other objects or other objects, the price would be, and sorry for my pseudocode, it will be for object in this objects inside. We're going to say price is 0, and we're going to say price is object get price. So why is it needed? It is needed so when you want to get a price of the whole complex box, for the complex box, you just say get price. So instead of another method calculate the prices of everything, blah, blah, blah. So let me clear the drawings. In example with the, let me skip it. With the example of the team lead and employee, see, they have, both of them, they have the same method bonus, but it is implemented differently. Since software engineer is a leaf in our tree-like structure, it just gives the bonus to themselves. Since team lead is a composite object containing the child employees, it iterates over the leaves and gives them the bonus. So do I have a CEO here? Why is it again happening here? Yeah, so I don't have a CTO here, but you can imagine that for a CTO, it's going to be pretty much the same thing. We create a CTO, and CTO also has a list of some employees. And these employees could be software engineers. These employees could be team leads. We don't care at this moment anymore, because when we want to give a bonus from the CTO perspective, this will call for each employee their bonus. So if the employee is a software engineer, they'll get their bonus straight away. If the employee is a team lead, then team lead will execute the whole bonuses for underlying employees, and so on and so forth. Let me read the chat. There is text annotation. Yes, I found the text annotation. Thank you. So let me stop it again and clear the drawings. And from the classes perspective, it looks the following way. We have some component, which could be a box, right? And then we have a leaf, which could be a product like phone, headphones, or with the example from the company, a component is going to be some employee and leaf is going to be a software engineer, and then composite is going to be team lead. And the whole point of this exercise is just to have a method execute that leaves and composite objects execute differently, but when a composite executes, it calls all the leaves inside to execute as well. So basically composite delegates all the work to the leaves. I can see the question in the chat, BFS or DFS. Basically, well, let's take a look at the code and maybe you can answer your question by yourself. Let's take a look. So we have a team lead. Let me draw again. We have a CTO, some CTO. And this CTO has an employee, and this employee has 2 employees like that. So let's take a look at the code, how it will behave. So if we're calling get a bonus for the CTO, bonus, it goes for all the employees, get employee bonus. For all the employees, get employee bonus. Okay, this is only one employee. He executes the bonus. For all employees, get the bonus. For all employees, get the bonus. This one. Okay, let me leave this one as well. So for all the employees, give the bonus. For all the employees, give the bonus. Ended. Next one. So this is going to be what? BFS or DFS? If it goes like this. I'm opening the chat. DFS. That's correct. So let's move on. Ending with the composite. When should we use it? Not when. Why should we use it, and why should we not? It is much easier to work with a complex structure, and recursion helps, right? So each complex object delegates the work to objects underneath. Why we shouldn't use it? In some cases, the methods of the simple and complex objects are way too different, and it could be laborious to generalize them. So maybe in this case, giving bonus to software engineer and giving bonus to a team lead are, well, sort of alike, but maybe they could be so different that it wouldn't make sense for a team lead to call bonus of software engineers inside. So in these cases, maybe you cannot use it. When to use? When your objects can be organized in a tree-like hierarchical structure, and when you want to treat simple and complex objects uniformly. So like have a single method bonus or a single method get cost of the whole package and each object inside the package. Moving on, facade. So as you can imagine, facade is something large that hides the whole implementation from you. If you go into a restaurant and you want to order some nice soup, maybe you just talk to a waiter or waitress. You do not see all the work happening in the kitchen. It's all hidden from you. You do not see all the work happening in advance, like when they are ordering the food, like to prepare like the ingredients, right? You don't see the whole work of cleaning the restaurant and kitchen. You don't care. You're only acting with the working with the waiter. The waiter is hiding everything from you. The waiter is your facade. So how about something closer to a real software engineering life? Imagine you want to create a video converter. Like you have an application that needs to convert a video. To do that, you have to call so many different components. You already have an audio mixer, you have a video file that you need to read, you have a bitrate reader, you have a codec factory, and so on and so forth. And you need to call all of them, right? There is a complex logic. You need to work with it. So instead of calling all of these guys inside your application, let's just create a small facade, small video converter. And that video converter will just have a single method convert video, and it will call all of these libraries and files and classes inside itself. So it will look like a following in the code. imagine you already have all of these classes, like I mentioned, and these are libraries. So like you cannot change them to make them nicer or better or shorter. So you just have to work with them as they come, as they are already. Then you create a video converter, and then you play with all of these factories and codecs and OGG and audio mixers, la la la. So all of this hard complex logic is hidden inside a single simple video converter that has a method convert. And yeah, this is a pseudocode also. This is not a Java. And then in your main application, you just create a video converter and you convert. That's it. You don't need to in every new application, you don't need to copy paste this whole bunch of the code and to make it messier or larger. That's it. That's the whole facade. Easy, right? So in terms of classes, there is a facade that contains lots of links to some classes, right? Like different smaller converters. And then it has just one operation, subsystem operation. You can create additional facades if you like. Maybe you want to separate this example onto two facades. Maybe there is one facade about strictly working with the video and another facade working with the audio. You can do that. But in this example, there's only one facade, and it's up to you how many facades you want to have. But there's also a caveat. Remember, if you are trying to hide all of the classes in your system under one facade, you may come to an anti-pattern that is called a God object. God objects are bad because they're too large, too heavy, and too hard to maintain because they're too large. So remember about it. That's actually a main disadvantage of facade. But as long as you don't overcomplicate your facade and keep it as little as possible, it's okay. So pros: complexity of the system is isolated and hidden behind a simple method, like we discussed. When to use: when you need a simple interface like a waiter with one command for complex systems, and when you want to structure your system into sublayers. Again, with the example with the video converter and audio converter. This could be two different facades. And the last one, but not least, a proxy. Who is a proxy? Well, basically sounds kind of creepy, but a proxy is needed when you want some object, your object, to pretend to be the one object, another one, which is provided to you, because it's simply better. What does it mean? Imagine you have some database and you have clients calling that database, but database is very slow and it also has a lack of logging and no metrics whatsoever. And you cannot change your database because it's provided by someone. Like, again, it's an external library. You don't have an access to a source code. You can only call that database. And also you cannot change your clients because, yeah, clients are also external. But you want to add some logging. Maybe you want to add some like smarter stuff, or you want to change the incoming requests in some way, or you want to cache the requests because database is stupid, and even if you ask the same request 10 times it will calculate it from scratch. So stupid database. You want something smarter. So instead of a database, you provide to your clients a proxy. So proxy pretends to be a database. So clients, they are unaware that they are not going to a database directly anymore because the interface is the same. But your proxy does some additional logic and then calls the original database. So let's take a look at the classes. So maybe here in this example, maybe you have some third-party YouTube library, and it can list videos, it can get video info, and it can download video. And again, it is stupid. It can, even if it downloads the video, it doesn't store it anywhere. What is this? Okay. So 1 second, 1 moment. Yeah. So even if it downloads something, it doesn't store it. And if you refresh your page, this stupid YouTube lib will download it again. We don't want that. We want something smarter. So we want to create our cached YouTube class. So our cached YouTube class will store a link to this third-party YouTube library. Well, this is an interface, this is the implementation. And then we can also download a video, but inside of this method, we're going to cache something and then call the original library. Let's take a look. So like I said, there is an interface, third-party YouTube library with these three methods. Then we have implementation of that method. We downloaded the library. And then we have our smarter class that you can see it can store stuff in the cache. And when we call a list videos method, it will check first if stuff is in a cache. If not, it will put the videos in the cache and then will return the cache.